What's up, math fans? I'm sure you already know what radians are because I did a video explaining what a radian is. And if you know how to convert radians to degrees, which I said you simply just replace the pi with 180, but what about if you're converting degrees to radians? So I like to explain it three different ways. One way is common sense, another way is using proportions, and the third way is a quick multiplication. But in order to do this, you of course have to know how to find a GCF or how to reduce a fraction like you learned in third grade. So let's look at 90 degrees. How could I write that as, or in radians? So here's something you have to know. There's a conversion factor. You have to understand that for every pi radians, that's equivalent to 180 degrees. So pi is to 180 degrees, and I can set up a proportion now. But just think about that. If pi is the same as 180 degrees, if pi radians is the same as 180 degrees, 90, if you think about it, what part of 180 is 90? 90 is half of 180. So if pi is 180, then half of pi got to be 90. So how do you write half of pi? You could write half of pi like that, or you could just write pi over 2. So 90 degrees is pi over 2. So that's the common sense way, or guess and check. Let me see. If pi is 180, 180 divided by 2 is, oh yeah, it is 90. I'm right. So you kind of go backwards. That's the guess and check common sense way, but you don't have all day for that when the angles get crazy like this. What part of 180 is 100? And then you kind of really got to start thinking critically. So there's another way to do it, which is the proportion way. So the proportion way would say, I know how to convert radians to degrees. So I put my radians on top and my degrees 180 on the bottom. And I'm going to create a proportion. A proportion is just two equivalent fractions. So let's see, I know that I want 100 degrees, but I don't know what the radians is. So that's x over 100. Pi is to 180 as x is to 100. And I'm setting up a proportion. How do you solve proportions? Well, you simply cross multiply. So I got 100 pi going this way and 180x going the other way, and that is equivalent to each other. One way equals the other way. I've done that 1,000 times. But I'm not solving for pi. I don't even need to use a calculator to get what pi is. Don't use 3.14 at all. So now I'm just going to divide by 180. I'm going to get my answer in terms of pi. In terms of pi means leave the pi there. Don't replace it with anything. So x is now alone, and my answer is 100 pi over 180, and that's it. But of course, like I said earlier, if you went to third grade, you know how to reduce a fraction. So let's try to do that. How do you reduce fractions? You look for the GCF, the greatest common factor. What goes into 100 and 180? I'm not sure. Some people do it the really painfully slow way. They just keep dividing by 2 on top and bottom until they can't go any further. Well, first of all, I'm going to divide by 10, because I know 10 goes into both. How do I know that? They both end in a 0. So I'm going to cross out the zeros. Now I'm looking at 10 over 18, and my greatest common factor happens to be 2 this time. 2 goes into 10 5 times, and 2 goes into 18 9 times, and I cannot reduce any further than that, so x equals 5 pi over 9. So that means 100 degrees is the same as 5 pi over 9. 100 is really 5/9 of 180. Don't believe me? Plug in 180 here, and it should work out. What about something like 23 degrees? That's even crazier. Well, you could play the same game. Just replace the 100 with 23, cross multiply, you'll get 23 pi over here, then you'll get 23 pi over 180. But 23 is a prime number, so there is no GCF, you can't reduce, and you're left with just 23 pi over 180. And that's okay too. Some people teach it, they don't teach the proportion way. The reason I teach the proportion way is because this way works for converting degrees to radians and radians to degrees. You would just have the x on the bottom instead of the top. So that works for everything. But some people might explain it by saying just take the given degree and multiply by pi over 180. So take 100 degrees and multiply by pi over 180. That's your conversion. Well, that's exactly what I did, just in an extra step. Because what did I get? Oh yeah, 100 pi over 180, which I just went through reduces to that. So one way is to use the proportion. The other way is to simply multiply by pi over 180. You're multiplying by that conversion. All right. I don't know, for some reason I like cross multiplying better because it works for every situation. But if you can remember this, this works for specifically degrees to radians. So last one, 330. Well, that's 330 times pi over 180, which obviously is 330 pi over 180. And I'm going to leave the reduction to you. Try to reduce that. Well, I gave you a hint already. The zeros go. 3 goes into 33 11 times. 3 goes into 18 6 times. So I got 11 pi over 6. Ooh, improper fraction? Doesn't matter. That's fine too. Thanks for watching. See ya.